My name's Josh Graham. For anyone who doesn't know, I'm the founder and CEO of EHAB. We've been working in the construction space for a little while now, and I'm really kind of excited to tell you a bit more about some of the learnings that we've been having around weather risk in the pre-construction phase of projects. Like I said, there will be a recording made available. I know there's people just joining now, so for those who maybe have joined slightly late, then you'll be able to get the recording and catch up with afterwards. And I think this topic is really, really important because it's just one of those topics where if you're living in the UK, then I've been staying in Devon, and I've kind of felt the full force of the recent storm. And I think we all know that weather is becoming something that is less predictable and more extreme, and therefore more important to think about at the earliest phases of construction planning. So I think it's a topic that's really pressing. And like I said, just to give a bit of background about who EHAB is, we were founded in 2020, and we're really lucky to be working with a lot of big firms who, see weather risk as an important topic and as something that they need to kind of strive to get better at. And so we're operational now on almost 200 sites. Most of those are in the UK. Oh, just getting a call. Most of those are in the UK, but we are now kind of expanding to North America and Canada as well. So US and Canada, and working on a real range of projects. So coastal projects, rail, road, all sorts of different types of projects. And so we've kind of seen the breadth of experience on these kinds of projects, which is something that I want to share with you. So I think I've chosen pre-construction. We've probably seen this type of diagram before. It is, it's something that kind of illustrates that the earlier in the project lifecycle that you can make changes and influences, the better. So, all in all, if you're able to influence cost at the conceptual stage, at the design stage, even when you're kind of in the early stages of procurement and planning, that is the best time to make changes in terms of the project cost and ultimately project timelines. And so I think that's why pre-construction is a really important phase when it comes to weather risk assessment, because a lot of decisions are being made at that phase, which are going to have implications for basically the cost and the timeline of that project. And so we are really recommending that if you're thinking about weather risk and how to do it better, it should be as early in the project lifecycle as possible. I think that's a fairly well understood concept. So that's kind of what I just wanted to introduce this with is the earlier in the process that we can get it, the better. And I'm now going to talk a little bit about how weather is kind of viewed today and how that I think is changing. So from a lot of the people I've spoken to across the years, basically winter working is the way that people think about weather. They think, okay, winter is going to be the time when I'm going to have the lowest productivity rates. So that is pretty much when I'm going to put time risk into my program. I'm maybe going to have a winter working calendar. That's going to be the way that I'm going to kind of factor in this, what this box plot kind of demonstrates. And as you can see, of course, winter is on average, the lowest productivity time of year. Summer being the highest, but there is obviously a range. And this box plot doesn't tell us anything about where this location is. It's a very broad high level. And so the more that you are, getting another call, sorry, keep getting called by people. The different places in which you're doing projects are clearly going to have different amounts of productivity rates when you are working on construction projects. And so it's really important to think like just using an average is not a great place to start, especially considering the changes in climate that we're having. And I'll explain this a bit later, but I think this is a useful kind of graph to demonstrate what the traditional thinking around winter working has been and why that's been there, which stands to reason. I think the next thing I want to introduce is the concept that temperature is a really big influencer on productivity rates. So it is right that winter working was kind of this concept that has been around for a while. When you see lower temperatures, it basically leads to a pretty steep decline in productivity. So you can see this kind of smile graph here, So the lower the temperature gets, you can see on the left, the lower the productivity rate gets. And also when the temperatures increase as well. So when they go above a certain threshold, there is also a lowered productivity rate. Not quite as severe as in colder temperatures. But what is really interesting is that there's actually an increase in accident rate, quite a steep increase in accident rate. So although winter working and working in cooler and colder temperatures has that lower productivity impact, when you work in high temperatures, there is this additional kind of maybe hidden thing that you aren't necessarily thinking about at tender phase, which is, you know, the safety impact. So that's one to bear in mind, and definitely something as we are seeing hotter summers, one to kind of consider and think about when making any action plans or any mitigation plans. And I think this graph overall is really useful to kind of just broadly summarize how underestimated weather is as a risk. So if you look at the kind of the pie chart, work type and temperature are the two, you know, jointly influential aspects to the activity productivity rate of a particular activity. But if you then combine all of those other weather types, of course, precipitation, humidity, wind speed, then actually ultimately weather comes out on top as the biggest influencer on productivity rates. And I think that really isn't thought about. And often people are really considerate of maybe temperature and wind speed if they're doing crane lifts, or precipitation if they're doing earthworks. But there is lots of other weather types, of course, that you maybe don't think about. So time and time again, when people are doing kind of that early phase of planning, you see someone thinking, right, concrete temperature, that's what I care about, or earthworks, rainfall, that's what I care about. And whilst those are the most maybe potentially significant and important, it's ignoring a whole bunch of other risks like humidity or like fog or like wave height that actually could be not maybe as influential, but could really be meaningful in terms of how you're accurately building out your program. So that's something that I just wanted to kind of put here to kind of start to again introduce this concept that weather is underestimated. And it's pretty obvious. Global temperatures are rising. We all know this, and the curve is getting steeper. It's really not slowing down, and so this has a lot of implications on the weather system. The most obvious one that if you're in the UK, you're going to kind of be thinking about is for every degree of warming, the atmosphere is able to hold 7% more moisture, which basically means more severe rainfall, heavier concentrated bursts of rainfall. But also because sea temperatures are rising, when there are storms that are coming across oceans, they're getting kind of, you know, you think of it like a supercharged hurricane is what they're kind of calling them now down in the Gulf Coast. But of course, that still effect is still happening for all types of storms that are making landfall wherever they might be. So yeah, thinking about that on the west coast of the UK, the storm that's just hit there was a pretty severe storm and very potentially exacerbated by the warming oceans. But how does that affect the different activities that you're working on a construction site? So on the bottom left there is a diagram, data basically looking at asphalting type activity. And you can see, so along the bottom is kind of the timeline. Since about 2014, there was a massive steep increase in the number of down days. So that graph depicts the total number of down days in a year if you were doing asphalting. And so that, you know, seen a massive spike in risk for that activity. And there's a lot of different activities that have that same sort of trend, like the hockey stick curve that is reflective of the other graph. You can see the global temperature graph. So that's really worrying because so many different types of activities, even very in recent years since 2014, are seeing that steep increase in risk. And it's kind of obvious as well, but all over the world, that hockey stick graph is relevant and happening. So this just happens to be a graph from the Gulf Coast, but you can see again, kind of since 2014, since 2015, there's just this uptick in risk that a lot of different locations are experiencing. So that those graphs that you can see on the right hand side there are the total average downtime of all construction activities combined at these different locations. And this kind of graph is reflected in a lot of places on planet Earth. So nowhere is safe from these types of changes. And of course, different locations are having different changes at different speeds in different ways. And I've already mentioned that rainfall is a really significant part. So the Met Office, you know, lots of data from there. But we're dealing with unprecedented amounts of rainfall, and particularly events where 50 millimeters or more falls. Those types of events are becoming more frequent, and those are the kinds of events that can really ruin your day when it comes to anything that you've not got out of the ground yet. So there's some serious thinking that needs to be done around mitigation preparation for if you're going to be doing foundations earthworks in the kind of the wetter parts of the year, in wetter parts of the country, then you need to think about that seriously. And I'm just kind of pulling out all the stops here to kind of just illustrate like how quickly these things are going to be happening as well. So everyone maybe thinks about sea level rise as a bit of a distant thing, but of course on the left hand side there you can see that the sea level rise will influence the height of the river in the Thames, and even by 2030, it's only 5 years away. These are the types of increases in flood risk. Zones that are not really exposed right now, but that are going to start to become more exposed. And the same on the right-hand side in Portsmouth, where most of the city, it seems, will be under threat from these kinds of potential flood events. So again, what we don't do today is think about flood risk in a kind of holistic way when we're doing tendering and bidding. Maybe if you're working on something particularly where there's been lots of floods in the past, you might be, if you're working on a certain motorway over a certain river, then you might be thinking about it. But are we looking at the flood maps that are projected going forward? Are you in a risky area that 3-4 years actually is potentially going to be at higher risk, and are you taking account of that when you're bidding for a piece of work which may be 5, 6, 7 years long? That is something that really needs to be taken into account when you're thinking about this. And we've been doing a lot of research, as you can imagine, to try to help understand how these changes are actually affecting project schedules. So we looked at lots of projects from 1990 versus 2020, and just looking at a few key differences in those projects. So the total number of down days is rising. That's just basically the total number of weather days that you could expect on a project has risen by about 8%. The standard deviation, so basically the volatility, the difference between the best case and the worst case scenario on a project, has risen as well. And then this likelihood of extreme delay, so basically a delay that could really badly affect the project timeline, has risen by a massive 1,500%. And so we're actually refreshing this piece of research now to bring it up to 2024, because we just expect those numbers to have risen further, and we'll make sure to be taking more and more data points from different places around the world as well, so that we can start to get a better picture of what that looks like. Because I think that this type of information is should be worrying if you're thinking about doing a project and maybe have been doing the same thing that you've always been doing in terms of how you factor in weather into your tender program. So I know I've been a little bit doom and gloom with all of the different data and the different things that from a weather perspective, but I think I'm going to kind of just focus in on some of the mistakes that I've really seen at tender stage, and that I think are important things to consider. So the first is one of the most common, and luckily I kind of feel like I'm seeing this less and less, but this is relying on kind of a gut feel approach. So maybe going back to that winter working calendar example, a common thing, maybe some of you have done this, okay, we've got a winter working calendar, we're going to knock out an extra day per week. Not sure exactly where that information comes from. It's not based on data for sure. It could be potentially based on some historic averages. The reality is, if you're getting a Met Office report and just looking at the averages that they provide there's a lot of assumptions that you're then going to have to be making to apply that to your schedule. And ultimately, this just doesn't result in a realistic program. There's just too much guesswork involved. And so that is just a really, really common one, not using any data, or if you are using it, just using those basic averages. So I think that's a problem that I've seen quite a few times. And I'm going to explain a little bit about some of the levels of maturity and how you can get to those later steps and later stages in a minute. The second part of this really is, if you have taken this approach, and I know client organizations are becoming stricter about understanding how risk and how time risk is being applied in schedules, but if you have taken this kind of gut feel approach, how are you supposed to explain that to your client? How are you supposed to justify the amount of time risk in your program? And I know that becomes quite a back and forth, a discussion. You have to basically try to create some sort of justification for it. And they're really, it's not easy to necessarily defend something where ultimately you just, it kind of is just intuitive, which maybe has worked in the past, but is definitely not gonna work going forward. So this concept of kind of too many assumptions, I mentioned it earlier, where people just focus on the really critical kind of known risk. So we know that concrete is going to be risky. We know that earthworks is going to be risky. Let's put calendars in the program for this, or let's make sure that we add additional contingency for these types of activities. But from what we've seen on those 185 different projects we're currently working on, near critical activities that maybe still are affected by the weather but aren't your key concern can push the timeline of your program. So it's better to be more thorough, have less assumptions, and ideally be as detailed as possible in applying these risks, because the reality is then you're going to have the most realistic program. You're going to have a much greater level of confidence in the different end dates and key dates and milestones that you have in your program. So I think that's really important, is to not just focus on the most critical risks. Obviously, time dependent, depending on the bid that you're doing. I think this one is a difficult one, because it is ultimately how the industry works today, but it is not necessarily having a process in place. So ultimately, if you're a planner, you're probably doing it a slightly different way to how all of your colleagues are doing it. And this means, I heard from a couple of people recently, they were looking back at plans that they hadn't made and the people had left, or different information, in the past that they, productivity rates and different kind of spreadsheets that they used to rely on. And they didn't know, they couldn't figure out what the mechanism was as to how someone had added that risk in or had come to certain numbers. So that's just, it's just one element of it. But then, if you then think about the entire organization all making different decisions, ultimately there's just no consistency. And so there's less predictability and a lower confidence in the result that you're providing, the schedule that you're providing. So having no kind of consistent plan is I think another thing that I hope will start to change more and more, as we kind of realize the impact that weather and climate is going to be having. And I think, again, I've kind of already mentioned this, but it feels quite reactive. It feels like people kind of just think about weather as something that you can claim as a compensation event, and trying to get better data to do that, as opposed to planning ahead to make sure that you don't have to make the claim, or planning ahead to make sure that you have the right contingency or you have the right mitigations in place. And that includes climate changes, like the kind of slide I had up earlier with the flood elements. Of course, if you're in a location where there is no potential flood risk in 2050, 2080, then great. But I think there needs to be and I know the insurance industry is kind of calling for better understanding of risks, not just when the asset is built, but throughout the project life cycle as well. Because of course, when you're building a construction project, you're really exposed to heavy rainfall and flooding. And that doesn't have to be flooding from a river. It can be surface flooding that just comes because of these types of heavy rainfall events that we're seeing. So I think the reactivity it is the kind of the final issue that I think is a bit of a mistake, and that we should kind of really try to rectify. So I mentioned this maturity scale. We have worked with a couple of different partners to kind of think about this, and it hopefully is pretty simple. There's 5 levels. The levels kind of indicate, so 1 being the lowest and kind of worst level when it comes to dealing and thinking about weather risk, and then 5 being currently where we think the best in class version of weather risk assessment is. I'll go through each of them, and it maybe is useful for you to kind of think about, where do you sit on this maturity scale. Most people, when I've done surveying, are kind of around the 2-3 mark. it's always a bit biased if I ask people on my webinars, because sometimes they're doing a bit better than the average. But if you kind of take away EHAB users, then you kind of get people mostly at level 2, 3. And I'll explain more in detail. So I hope everyone kind of understands level 1, which is probably what most people are not doing, which is just doing nothing. It obviously depends. You may do nothing if you're kind of used to working in a certain area and you're comfortable with what you think the weather risks are in that location, and that may be the case. But this, the advantages that it is very quick and simple because you're not doing anything, and the disadvantages are that you're basically ignoring the risk and pretty much hoping for the best. So of course if there are risks, weather risks there that are hidden that you're not factoring in, then you're very likely to run late. Level 2 is like I said, is very common approach. So you are taking some consideration of risk. Usually it's happening as the planner is going. So you're planning a concrete activity in February and you're thinking, okay, I should add in a couple of extra days here. Or you're doing lifting in April or March or May, and you think, okay, well, it's not usually that windy at this time of year, so I will only add an additional day. The disadvantages is that as your program moves around, you kind of have to kind of rejig and kind of rethink about how much padding is in each activity. Of course, you don't know if you're actually adding too much or too little because you're not using any data to necessarily extend those durations of those activities. You're just kind of adding risk in. And actually a recent thing is you don't know what risk is what. So it's not discrete, it's not explicit in the sense that you've said, okay, one day is for weather, one day is for logistics delays. You're just kind of broadly saying, okay, I'll throw some risk in here. And so ultimately it means your program isn't realistic, and then there's manual work that has to be done as the program shifts around. Level 3 again is a better approach than the previous level. It also allows for the kind of seasonal nature of weather, which, as we saw right at the beginning, with the kind of is very clear and prominent. There is an absolutely obvious seasonal impact that weather has. What this means is you're using calendars in the schedule. So you might create a concrete working calendar, for example, or like I said, a winter working calendar. If you use a winter working calendar and you're just kind of populating it with your assumptions, then that is one kind of worse approach, but you might also be populating it with data that you've acquired from somewhere. So if you're at this level and you are actually getting data, trying to do a manual conversion or figure out how many days might be relevant to different activities, then that is a good approach, because you are enabling, as your program moves around for whatever other reason, the underlying calendar is going to stay there. And it means that, as that shifts around, you don't actually have to do the work to extend the program because the calendar does that for you. It's still not the best approach, and you're probably looking at averages, which, climate change is making weather worse on average, but it is also making the extremes much, much worse. So you kind of ignore the long tail kind of black swan events a little bit, just because of the simplistic nature of it. But I would say that that's a decent approach. Level 4 is, I think, what if you're at level 3, it doesn't take so long to switch over to this version, which is basically where you are actually using a quantitative schedule risk analysis tool. So QSRA or QRA. So it might be a Safran risk or a PRA, or the Oracle online version, OPC. Nodes and links is another one you potentially could use for that. Basically what this is doing is you've run your schedule through this kind of Monte Carlo simulation, and you've used different solutions have different features, but you've kind of put some weather calendar in your risk assessment, again, which factors in there's more risk in winter, there's less risk in summer for weather, and depending on how much time you have or how much information you want to put into this, you can separate it out by different activity types as well. So one of the features of EHAB is to let you automatically create these calendars, which is how you can kind of get to level 5. But in level 4, it's probably a manual process of, again, getting weather data, having to kind of work it into a calendar. And what I have kind of seen people do is just pick one location for the whole, for a very large area. I don't know if it was the whole of the UK. It might have literally been north and south, and use a calendar based on some station there. So yeah, they have used data to kind of inform the creation of the calendar, but it isn't site specific whatsoever. It's kind of very, very broad brush. And then level 5 is where you actually kind of assess all of the different activities in your program. You have calendars for each of those activities, and the data that has gone into each of those calendars is specific to the location you're in, probably using satellite data and other things that I'll explain later, but basically taking a really scientific approach, again, using probably a lot of automated tooling, because to do this manually would just take way too long. But the reason it's the best approach is because when you're then running your quantitative schedule risk analysis, every single different type of activity has different types of weather risks that it's going to be exposed to. As your activities move around in that model, and they'll be basically running different probabilities of impact based on, in Safran, it's every single day. In PRA, it's every week. In Acumen Risk, it's every month. There's different probabilities of impact, but it just means that as your activities move around, it's not just saying, flat this number of days. There's a probability of a certain amount of weather impact, and then that gets factored into the simulation. And it just means that that whole simulation, as it moves around in time, is factoring in weather in kind of the most detailed way. So that's the maturity scale. I'm really curious, maybe if you want to comment what level of maturity you are in, and kind of what your experience has been in doing that. But yeah, I'll kind of move on now, and I will share this spreadsheet, this slideshow at the end as well. So what I would like to do now is actually just talk now a bit about what are the overall kind of things that you probably should do if you want to take a more data-driven approach at tender. A lot of these things EHAB can help you with, but all of them could be things that you could do separately as well. This is just the way that we believe is the kind of the optimal approach, and it's thinking about it from a whole org perspective. The same process would be gone through on a project level, but yeah, this is kind of focused on how can you make your whole organization take a more data-driven approach at the tender stage. So thresholds. It's really difficult to understand how your project is going to be impacted by weather if you don't have a common shared understanding of thresholds, of what is going to influence different activities. So we really recommend that you create some kind of standardized risk matrix. It can just be a spreadsheet, or in EHAB, it's kind of again, effectively a spreadsheet where, for example, on the left, you can see we've got in situ concrete. We've said that the daily maximum temperature that you can pour concrete in is 35 degrees, and the daily minimum temperature is 3 degrees. You can kind of see there's some colorful bars to the right, which just broadly indicates, because this is from the EHAB platform, the probability of impact of that rule in the location that you selected. And so you can see most of the other rules are fairly pretty much green, although that doesn't mean 0%, it just means below 20%. But you can see for the 3 degree rule in the winter months, it's got a 43.3% probability of impact in March. You want to create a standard set of thresholds for concrete, because even if you're doing your concrete activity in different locations, the threshold doesn't change. The degree at which you pour concrete doesn't change. It's just the underlying data that does. So if you can get this standardized kind of understanding of how your organization is impacted by weather, that I think is really important. So the right-hand side is just kind of a spreadsheet which lists different activity types, and then you can kind of, you can get the sense that maybe it's useful to know what our limits are for all of these different types of, for topsoiling and internal fit out, and of course internal fit out wouldn't have anything, but you can make sure that you understand what are the ways in which your organization is impacted by the weather. I think that's really the first step that when we work with any clients is kind of get this shared understanding. Then the next part of it is making sure that your schedule has kind of some of these key aspects of data integratability built into it. So when you're building a schedule, when you write the name of the activity, obviously you as the planner know what activity it is. You write the formwork or whatever it is that describing the activity, but there's no code that would enable you to maybe match it up to other systems. And so this is actually fundamental to anything, not just weather risk. Like if you're trying to do any integratability of your schedule into other solutions, using activity codes is a really obvious and beneficial way to do that. And so, yeah, kind of the concept is, okay, I know I've got an earthworks category because I've named it as earthworks, but you need an activity code in the background that says, well, this is earthworks, this is lifting, this is concrete, so that you can basically have a more data-driven approach to how your schedule is kind of annotated. And it just means that, for example, if you're putting your schedule into EHAB, we know which activity is which to match to the risk matrix. So this kind of ties in with the previous step. You've built your risk matrix, which has earthworks, lifting, concrete, and then your schedule actually has codes in it so that you can match your risk matrix to your codes. So if you are going to be trying to run anything, even in a spreadsheet or in any of the other risk solutions, you know what activities are which. It also has other benefits around reporting and lots of other things. But this is really key for kind of doing a weather risk analysis. And I think it's probably fairly obvious, but you need to have data that is specific to your site. So nowadays, there's like a huge amount of satellite data that you're really going to want to be leveraging because, obviously ground station data is great because it has the historical, the long-term aspect, but we still have, satellite data going back quite a long way. And so I think it's important if you are working in a more rural location, if you're working in a place which has not got a Met Office weather station nearby, then making sure that you can try to get access to some information that's going to help you fill in the blanks. Because the last thing you want to do is rely on a Met station that's 20 miles away and find out that your site has way more risk than you were necessarily expecting. And it's a bit of a buzzword. Everyone's heard about it, AI. There's a lot of new things coming out. You've probably seen Google, Nvidia, IBM. They're like all doing different things around weather forecasting. And so basically AI is kind of changing the game on this front. So it's really important that you at least consider it. And I'm happy to kind of share some resources afterwards if people are particularly interested in that. The final thing to say is the default go-to is the Met Office. And I know you've probably all seen the spreadsheets, you probably all used the averages that they provide. There's a lot of gaps in where those Met Office stations are based. And so that's really why I recommend you using satellite data and artificial intelligence to fill in those gaps. Because distance is an obvious thing. If you're working in the middle of the Scottish Highlands or somewhere where you're not close to a Met Office station, then it just means that you're going to be kind of flying a little bit blind, and you need to kind of combine different data sources together. This one, I think, is kind of, so once you've gone through these initial steps of setting up your risk matrix, of making sure there's coding in your program, and making sure that you've identified what data sources you're going to use for a particular job or for your company in general. And I think it's useful to also think about, well, maybe I want to take a different risk approach for different contract types. Because you may not want to throw all of your resources at every single project always. It may be that you want to be tailored in your approach to this. So I think if it's a low risk, low value job, then maybe you can kind of get away with just getting a basic report. Maybe that's the Met Office report, or maybe it's one of the reports that we can provide. Something that just kind of gives you a high level, okay, is it on a floodplain? You know, what are the types of risks that I'm likely to be exposed to? Something that can at least, you know, if you are going to be applying just contingency into the duration of your activities, making sure that you use data for that location to make those decisions. For kind of mid-risk, mid-value, then maybe you want to run your schedule through some sort of model, whether that's a spreadsheet that you've built yourselves or the EHAB tool or another tool out there, so that you can get a much more accurate time risk allowance, maybe either using the calendars or just using one of the reports that comes out of the solution, so that you can just basically say, okay, well, we've got these 1,000 activities of these different types. The model that we've built or the spreadsheet says, you know, it's going to be 25 days that we need to add. Just something that is kind of, yeah, a more automated but a more streamlined process for you to add that time risk in. And then, yeah, I think if it's a high risk, high value job, then probably you do want it to go through a full QSRA process. That's just going to give you the most accurate results. And the way that EHAB integrates into the QSRA solutions, for example, does not add very much time onto the process. So yeah, the idea that you should just have this as a kind of a business as usual for your larger, bigger jobs, I think can be done. And so yeah, you may just want to think, how do we approach this? Maybe you just say that we always do QSRA on all of our jobs, or maybe we just make sure that all of our jobs have a certain level of baseline, and then we target certain jobs with some additional data. But I think we just need to step away from that kind of DIY, let the planner do it themselves type approach, because of course planners aren't meteorologists and climatologists. So getting them to take those kinds of decisions, yeah, it's kind of it's leaving too much up to chance. And of course, you want to do something that's scalable. So you need to take an approach which is not going to take lots of time. You know, obviously, as you all know, new processes are difficult to implement at the best of times. And so I think, obviously, what EHAB is trying to do is make it so that it's as easy as possible for as many people as possible to go through the same predictable, repeatable process. And obviously, maybe the first time they use it, it's a little bit difficult, but then the third, fourth, 20th time that you run a model and run a scenario through EHAB, then you know how to do it, you know how to interpret the results. And you know, obviously on our side, we're always trying to improve the way that those results are generated and the way that that information is displayed. So regardless of whether you're using EHAB or not, just creating a process that is repeatable, that you can kind of understand and is easy for people to follow, or at least easy for them to learn, that is obviously really critical, because yeah, as I've already kind of alluded to it and said, if weather risk isn't something that you're concerned about on a particular job now, in the next few years, it really will be, because weather risk is not going away, and it's only going to get worse. So creating that kind of scalable approach is definitely the way forward. And I just want to kind of highlight a little bit one of our longest standing partnerships and customers, because this is exactly what BAM have done. They have taken a really, I would say, aggressive approach and are trying to make sure that as many projects as possible, depending on the level of risk, goes through some sort of weather risk process. So at the moment, we're working on I think it's about 50 schemes of BAM with BAM. I know there's a couple of folks on the call. So yeah, a large number of schemes. I think it's actually more now. And all of those have been through a weather risk process at tender, and then often they're still using the solution as the project moves through the life cycle. And really the interesting parts that are kind of the beneficial things that we found is first of all, it's actually quicker to run a digitally enhanced, more kind of science-based approach. because there's less negotiation and discussion with the client. There's less back and forth. There's less having to justify and create slides and do all this stuff, because all of the information is kind of there in the system that you can print the screen and include in your reports. And so you don't have to, you've justified it by the very fact of illustrating the process that you've been through. And of course, if your client is then accepting of that information, and usually it is adding more contingency because risk is going up, generally the weather risk is going up, then you're going to get better contingency margins in your program if you can justify this. Now, obviously, it really depends on the client. It really depends on how you're working and if your client is going to be ready and willing. But the reality is, if they aren't, then they're going to be accepting that risk regardless of whether they include it or not. And that's just going to lead to problems down the line. So I think it's important that at least you have the evidence that can try to support that. And yeah, I think we've got buy-in from a lot of the folks at BAM in terms of using it. And of course, there's always improvements to be made. We absolutely want to kind of continue to improve the way that the solution is delivered. But it was great to kind of be recognized as well as one of the project controls innovations of the year, because I think, again, the recognition from that is that weather is important, and we need organizations like BAM who are trying to take the best in-class approach to this. I'm just going to kind of close with some of the bigger benefits that we've kind of seen across the different organizations we're working with, and then I'd really love to kind of open up any questions or answer any questions. Sorry, I've not actually been looking as I've been going through. So we're really trying to build a holistic approach, something that is strategic, so that if your organization does any projects outside where they are exposed to weather, you have the information from a weather and climate perspective to kind of take a better approach. And I think we've kind of proven that we outperform the traditional approach in a lot of ways. So our model at the moment is about, on average, 94% accurate at predicting downtime, and that's even multiple years into the future. So what we're not doing is forecasting the weather, because if you've ever used the BBC weather app or any other weather app, you know that forecasting is really difficult, even with the new AI approaches, which are good, but still you can only kind of forecast about 2 weeks out. What we're saying is, what is the probability of me achieving a certain activity 3 years into the future based on weather thresholds, historic data, climate data, and that's where we can really get a lot of accuracy, because instead of saying a specific weather type or outcome where it's going to rain on this day, it's just saying, well, the probability of it being a weather down day is this, which could be any of the weather types happening in that location. Across the different projects in our portfolio, on average, it's saved about 10 days per year. So just think about whatever your prelims are and think, okay, if I could save an additional 10 days on a job, that might be finding a strategic acceleration opportunity, or it might be managing to get additional days into your time risk allowance pot, or negotiating a bigger risk pot. It's lots of different ways, but that's kind of just broadly how we've summarized it. And when we compared it to some of the older, more traditional approaches, it has a lot less error than the current approach, and it's also quicker. So yeah, a lot of the feedback from BAM and the previous slide is around actually, if you run this process, then you save time, because it becomes something that just is kind of digitally enabled. You just have to click a few buttons. You no longer have to have those discussions and arguments with your client, or at least a lot less of them. And that's kind of the broad spectrum of benefits at the pre-con phase that you can kind of expect if you are using a more digital kind of enhanced approach. So we may not have time for a quick demo, but I'm happy to. We've got a new kind of tool called Climacast, which I will happily send out to you, so that you can have a little play around with that as kind of a free demo. So I'll send that out to you afterwards if you wish. But I'm going to stop sharing my screen and I'm going to answer any questions. I realize because it's on webinar mode, you can't speak at me. So I'm going to go just stop sharing my screen and see if we do have any questions. So yeah, Matt. So Matt says, hi, thanks for the presentation. Do you have any thoughts or suggestions on the rating and managing ongoing change to time risk allowance quantities with clients? I feel this is the biggest hurdle. Awesome, Matt, is a really good question. So one of the things that you can do kind of at that early stage of tender, right, is if you are able to assess the weather risk with a kind of science-based approach where you can kind of explain, well, this is the data that we got, and this is the way that we've applied that data to our activities, which, you know, if you remember, it's kind of thinking about, can I use activity codes? Can I kind of apply some sort of set risk matrix, set of thresholds to my activities? And then that, you know, even using a basic spreadsheet, you should get an output which says, okay, for concrete in January, I'm going to have this many days. Concrete in February, I'm going to have this many days. And if you can use that as part of the kind of the toolkit when, let's say, a change has happened. So yeah, there's been a compensation event from your client, for example, because they've changed the scope or some other delay has happened. And obviously you then have to kind of do a clause 32 and think about, okay, we've got a rebaseline. I guess the simple way is just to think, okay, some of the key risks that I have, how many additional weather days might we get? And I've seen people using like a spreadsheet calculator to do that before. That's obviously going to be quite rough and ready, and there might be a fair bit of work involved. But if you can use the same set of information that you had at the beginning to use throughout the process, like the same thresholds, the same weather data, then that's going to, you know, you can show like, look, we've moved from January, we're now in December, and this has this differential in risk. Then I think that starts to help explain it. In EHAB, we have a functionality which allows you to compare two versions of a plan, and the full model will have run, and then you basically get a report which says, this is the total number of weather days that has changed. These are all of the activities where that weather differential has occurred, and these are the reasons why. So, you know, a concrete activity has moved from March, and that's now in September. That has a difference of 4 days, 4 additional weather risk days. And again, you've got the justification because you've got the data that you know is the same that you've already been using. You've got the thresholds that are applied. You've not changed the thresholds. It's the same set of thresholds. It's just that the risk at that time of year is different. So I don't know if that answers your question, Matt. I guess maybe one final point on it is the more repeatable the process, I guess the more that you can refine it. So if it is a process that all of the different planners in your organization are taking and able to have that discussion with the client, then you'll see what is working and what isn't. So I know that whenever I'm at conferences speaking, people are always like, oh, how is the client going to accept this? I mean, the reality of it is, yes, we're on a lot, almost 200 jobs. And in many of those cases, I know that we used at bid phase and that the clients accepted the risk. And I know that as they go through the process and are submitting clause 32s as part of the NEC, for example, that time risk is being accepted as well. I'm not in the room. I'm not in the room every single time hearing those discussions, though. But it'd be great to kind of hear from people how they're doing that, because yeah, it would be really useful learning. Is there any other questions or thoughts from anyone else?